morning. By now, we've learned how to differentiate functions of the form y equals some function of x, whether that function of x is a polynomial, whether it's a polynomial with an external exponent requiring a chain rule, whether it's a product of two functions of x or a quotient involving two functions of x. We've learned how to differentiate those types of functions where y is isolated. So in our lesson today, we're going to look at implicit differentiation. With implicit differentiation, you do not need y to be isolated in the equation in order to find the derivative dy by dx or y prime. And the two main formulas are listed here at the top. And these are not new to you. So if you're taking the derivative of a term and it's in this form, x to the n, the derivative is n times x to the n minus 1. So we use this when we differentiated polynomials. Now, if you have a function of this form, y to the n, and here we're assuming y is some function of x, then its derivative is found by the chain rule. So n in the front, n minus 1 for the exponent, but then we must remember that we would be multiplying by the derivative of y itself. And in the chain rule examples we've done so far, this would correspond to the derivative of the inside of the bracket. Okay, so keeping these two things in mind, we're going to try this first problem. We've got x squared plus y squared is y cubed minus x, and we're going to be finding dy by dx. And you'll notice here we don't have y isolated. We do not have the form y equals. So we're going to differentiate this implicitly, which means just going and taking the derivative of each term where it is in the equation. So we start with the leftmost term, x squared, and we write down its derivative. So what is the derivative of x squared? It is 2x. And then we put in our plus sign. Now, what is the derivative of y squared? Y squared would have a derivative equal to 2y to the 1 times dy by dx. So we get 2y multiplied by dy by dx. Okay, equal sign is next. Now we take the derivative of this term, y cubed. What's the derivative of y cubed? 3y squared times dy by dx. Minus the derivative of x, of course, is 1. Right? It's x to the 1, so its derivative is 1x to the 0. 1x to the 0. Okay, so I think this question highlights the main difference here. For the derivatives of x squared and x, we use the top rule, and for the derivatives of y squared and y cubed, we used the second formula listed. Okay, now we're certainly not done because the objective is to solve for dy by dx. You can see that it's part of this term, it's also part of this term. So all we have to do is combine like terms now. So I'm going to put the two terms with dy by dx on the left side. Okay, so when this term moves to the left side, of course, we have to use subtraction. And the two terms without dy by dx, I will put on the right side. So this one is already on the right side. And when this term moves to the right side, we have to use subtraction. All right, so now we've got the like terms combined. Now we want to solve for dy by dx. So that means removing it as the common factor in the left side. So when dy by dx is removed from this term, it will leave 2y. Now we have the subtraction sign. When dy by dx is removed from this term, we will have 3y squared, like this. And this common factoring can be checked. If you open up the bracket using multiplication, you should get this line here back. Okay, lastly, we solve for dy by dx, and this will involve division. So our final answer will be -1 minus 2x over 2y minus 3y squared. So it's an expression for the derivative dy by dx for the given equation. Okay, so we're going to look at a second example here now. Find y prime. Of course, y prime is the same as dy by dx. If now we have this x squared times y cubed is 5. So problem 2 is different because x squared, of course, involves this formula, y cubed involves the other. They are in the same term, and in fact, they are multiplied together. And we didn't have that here. We had 4 separate terms. We had no term that had both x and y in it. This kind of term is handled with a product rule. So what we have to do is we have to say that u is equal to x squared and v is equal to y cubed. And so if I'm going to be using the product rule on this term, it'd be helpful to first write down what I'm going to be using for u prime and what I'm going to be using for v prime. Okay, so u prime is the derivative of x squared. And the derivative of x squared is 2x to the 1, so 2x. V prime is the derivative of y cubed. What is the derivative of y cubed? 3y squared times dy by dx or y prime. So 3y squared times y prime. I'm only using y prime instead since that's the notation in the question. So now what we do is we use the product rule for the derivative of the left side. So do you remember how the product rule goes? If not, don't forget it's included on the formula sheet posted in Blackboard. Okay, but it is, just as a reminder, the derivative with respect to x of u times v is u v prime plus v u prime. So this is what I have to write down now on the left side is u v prime plus v u prime. So in this case, it will be u times v prime plus v times u prime. Okay, u v prime plus v u prime. And that's the derivative of the left side. And now we're here at the equal sign. And we have to take the derivative of this term also. What is the derivative of 5 or any constant at all? Its derivative is 0. Okay. So, and you know, you could think of this as being 5 times x to the 0 to remind yourself of why its derivative is equal to 0. Okay, so now I'm looking at this, and remember what I'd like to do is solve for y prime. It makes sense, though, before we do that, to rewrite these terms in a natural reading order. So that would be for this term, the number the x squared, the y squared, and then the y prime. Okay, so that's the natural order when these things are multiplied together. After the plus sign, same thing, the number, the x, and then the y term, like that. Okay, so now these terms might look more natural to you. And we're trying to solve for y prime. One term contains y prime, the other doesn't. So we'll move this term to the right side. Where it will be negative 2xy cubed. And then to get the y prime by itself, of course, we use division. So we end up with negative 2xy cubed over 3x squared y squared. And that's just about perfect, but we can reduce this fraction because we can cancel 1x from numerator and denominator, and we can cancel y squared from numerator and denominator. So that means, so fractions should be in reduced form. So that means we will have negative 2y over 3x as our final expression. Okay, so when comparing examples 1 and 2, remember that the product rule had to be used in problem 2 because this is one single term. There is no plus sign or minus sign here, so multiplication is assumed. So inside one single term, we have both x and y. That's why we have to use the product rule there. Okay, and in number 1, instead we had 1, 2, 3, 4 separate terms divided up by these operators, the plus sign, the equal sign, the minus sign. And in each of those 4 terms, there is either x or y. Okay, we'll do one more together. This one is problem 3. It says, determine dy by dx, or the derivative of y with respect to x, at the point negative 1, 2, given x squared minus 3x cubed y is y plus 5. Okay? So we're going to use our implicit differentiation. So we first look at this and decide how many terms we have. Okay, so remember these operators separate the terms. So we have 1, 2, 3, 4 terms. So 4 terms in question 3. And now look at the terms and determine if any of those terms are going to require us to use the product rule. So hopefully you'll note that right here, we're going to have to use the product rule because in this one term, we have both x and y. So if we're going to use the product rule in that term, let's make u equal to 3x cubed and v equal to y, like that. So you have to divide x's from y's when you label these. So that's u and that's v. Okay, and since I'm going to be using the product rule for that term, I might as well at this point in time figure out what we're going to use for both u prime and v prime. Okay, so u prime is the derivative of 3x cubed. So its derivative is 3 times 3, or 9x squared. So 9x squared. Okay, so it's the derivative of x cubed multiplied by 3. And the derivative of x cubed, is 3x squared. So it's 3x squared multiplied by 3, or 9x squared. What's the derivative of v? Now, the derivative of v means the derivative of y. You can consider y to be y to the 1, right? What is the derivative of y to the 1? It's 1 y to the 0 times dy by dx. So 1 times y to the 0 times dy by dx. Or 1 times 1 times dy by dx. Okay, and that should make sense to you anyways. What is the derivative of y? dy by dx is the derivative of y. Okay, but again, you can consider it to be y to the 1 if you like, if that's helpful to you in forming your derivative. Consider it to be y to the 1, and then you get 1 times y to the 0. And y to the 0, of course, is 1. Okay, 1 times y to the 0 times dy by dx. Okay, so that's u prime and v prime, and we'll need that when we do the derivative of this term. But we start, of course, with the leftmost term. So what is the derivative of x squared? It is 2x. Now we have a subtraction sign. Now remember, what is our product rule? Well, we just wrote it down here. It's uv prime plus vu prime. But the key is it's a binomial. It is 2 terms. So there will be 2 terms following this subtraction sign, which means I need to put those 2 terms in a bracket. Okay, so now we do u times v prime plus v times u prime. Okay, so the derivative of x squared, the subtraction sign, and then in a bracket, the product rule, uv prime plus vu prime. Multiplication, of course, here and here. And that's multiplication is assumed between u and v prime and v and u prime here. Okay, so now I'm at the equal sign. Now I have to do what is the derivative of y? The derivative of y is dy by dx. Now I'm right here at the plus sign. What is the derivative of 5? The derivative of 5 is 0. Okay, so we took the derivative of 1, 2, 3, 4 terms, making sure that when we differentiated this term, we used a product rule. Okay, so now what should we do? Well, we should distribute this negative sign into the 2 terms here. So it will be negative 3x cubed times dy by dx. And it'll also be, this term will also be negative. Okay, because it's like a negative 1 being multiplied inside the bracket. So the second term here will also be negative, but natural order for that term would be 9x squared y. Okay, so negative 1 is multiplied inside of the bracket, but for this term here, we use the more natural order, numbers, x term, y term, right? Okay. Now we take a look at this, and we see that 2 of the 4 terms contain dy by dx. So we must get those terms on the same side. Okay, so you could either bring those terms both to the right, all right, which would actually maybe be nicer because then they'll both be positive. Or you could bring them both to the left. So I think maybe I will bring this to the right so that I can have both terms positive there. So staying on the left will be 2x and negative 9x squared y. Already on the right is dy by dx. So the only term moving for me is this one. So of course, on the other side of the equation, it will be added. So plus 3x cubed dy by dx. So this is collecting like terms. 2 terms contained dy by dx, 2 terms did not. Okay, so now remember, I'm trying to solve for dy by dx, so I have to remove it as common from these two terms. So dy by dx is common factored from the two terms. I must have two terms in here. dy was here. dy by dx was here, and it is what was common factored. You have to leave behind a factor of 1. So you're doing dy by dx divided by dy by dx is 1. Now put in the plus sign and divide this term by dy by dx, and that will leave you with 3x cubed. Don't forget, if you used multiplication to open this back up, you should get back the previous line. Okay, so that's common factoring dy by dx. Finally, to get the dy by dx by itself, you must divide by this binomial. So we end up with this expression. Okay, we have 2x minus 9x squared y all over 1 plus 3x cubed is our expression for dy by dx. Okay, this question asks us to evaluate dy by dx at the point -1 and 2. So now that we've finished developing our expression, we simply will substitute this x value and this y value. So that will look like this. 2 times -1 minus 9 times -1 squared times 2 over 1 plus 3 times -1 all cubed. Okay, so everywhere there was an x, we substituted -1, and wherever we had a y, we substituted 2. Okay, so this is 2 times -1, or -2, minus 9 times, now -1 squared is +1. If you want your calculator to figure that out for you, you have to actually put brackets around the -1. It has to be -1 all squared will give you 1. Okay. While if you cube -1, -1 all cubed is -1. Okay, so now in the numerator, I'm going to have -2 minus 18. And in the denominator, 1 minus 3. Okay, so -20 over -2. And so this means we end up with dy by dx is equal to +10. Okay, so if you're given a point at which to evaluate the derivative, you cannot substitute that point until you've fully completed your derivative. Once you have that expression, now you can substitute both your x value and also your y value. Okay, so that was a lesson on implicit differentiation. I have recommended a few problems from your textbook. Yeah, that's it, I guess. I hope this goes all right for you. And you guys have a great day.